Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 36 to 37 of the June 2016 Algebra 1 Common Core New York Regents exam. All right, let's take a look at question 36. It says, on the set of axes below, graph g of x, which is 1/2 x plus 1, and f of x, which is the piecewise defined function, 2x plus 1 when x is less than or equal to 1, and 2 minus x squared when x is greater than 1, negative 1. All right, so let's go ahead and graph the more complicated function first, which is a piecewise defined function, okay? So what does a piecewise defined function mean? It's basically a function defined in different pieces or different intervals of the coordinate plane, okay? Here we have two pieces. Let's call the first function 1 and the second one 2, okay? So there's a partition here that separates the two functions, and you can easily determine it by looking at the inequality. All right, this is less than or equal to -1, -1 and everything to the left. This is greater than -1, everything to the right of -1. So this is where your partition is going to be, okay? So let's go ahead and partition our coordinate system accordingly. You just simply draw a vertical line through -1. X equals -1, okay? All right, so there you have it. So what we're going to do is we are going to plot the first function in this half space right here. This right here is plane 1, okay? And then this right here is plane 2. So we're going to put the first function, we're going to plot it right here, including the line. So wherever it touches the line, you have a closed circle. And then we're going to take this quadratic function that has been reflected and shifted. We're going to graph it in plane 2, excluding the line. Okay? All right, so let's do it. The first one is just a line, so we can do that by hand. We don't need to use a calculator. So for graph 1, we have, you can write y equals 2x plus 1. The slope is going to be 2 over 1. So we're going to rise 2 and run 1, starting from +1. That's your y-intercept, okay? So you graph +1, and then you're going to rise 2, 1, 2, and run 1. Now, since this line is restricted to the second plane right here, let's go ahead and graph the points that fall in that plane, okay? So if you rise 2 and run 1, is equivalent to dropping 2, 1, 2, and backing up 1. All right, you get collinear points here. Drop 2, back up 1, drop 2, back up 1. Okay, so those points are sufficient to draw line 1 of f of x. So you draw your line like this. Okay, now recall that we have an inclusion line in the inequality, okay? You see this line right here? That means that this line includes the boundary points too. So where the line touches this partition, you have to have a closed circle. Okay. All right. So now we have that taken care of. Let's go ahead and erase the point. Now we have the second plane opened. Guess what we're going to do? We're going to graph this quadratic function on the second plane right here. Okay. Now if you look at this quadratic function, the second one, I'm going to show you how to do the calculator, but before that, look at this. If you have y equals 2 minus x squared, if you write this in standard form, you're going to have -x squared plus 2. Okay, so this is a quadratic function that has been flipped downwards and shifted 2 units up. Okay, so if you just shift a quadratic 2 units up and flip it down, it's going to look something like that. Oh, that doesn't look good. Something facing downward. Okay. All right, so that's just a general pattern. So let's use our calculators to help us determine the coordinates that we're going to use. We can maybe use about 4 coordinate values, or maybe 5, to make sure our graph is perfect, okay? All right. One thing you want to notice is that this graph wasn't shifted horizontally, okay? It was only shifted vertically. So our graph will be centered. The line of symmetry will be the y-axis. Okay, so let's plot it. We have 2 minus x raised to the second power. Enter. All right, here's the graph. And there you see how the graph looks. Okay, but we want the points starting from -1 all the way to the right. Okay, so let's go to take a look at our table. I don't know what the setup is yet. Okay, let's see. Oh, nice. Okay, so let's just copy down those points. We have 1, 2, 1, -2, and -7. So 1, 2, 1, -2, -7. Okay, we started from -1, 0, 1, 2, 3. Okay, so let's take a look at it again just to make sure I didn't mess anything up. So -1, 0, 1, 2, 3. All right, so these are the points we're going to graph. Okay, so the first point is on the partition, -1, -1, 1. So the question is, so let's graph it first, -1, 1. Is this going to be a closed or open circle? This point right here for the quadratic function. There is no line underneath the inequality, which means that it's excluded. Okay, that point is excluded from the quadratic function. So -1, 1 will be an open circle. Okay, now the vertex 0, 2 is closed. Everything else is closed. 1, 1, 2, -2, and then last one, 3, 1, 2, 3, -7, 1, 2, 3, 4, 5, 6, 7. Okay, so these are the points that defines your quadratic function. So we'll just simply connect the dots. Okay, so there goes f of x right there. So it's kind of like a rough sketch. So this entire function we just drew is f of x, all right? Now let's go ahead and graph g of x. G of x is a straight line, so that shouldn't be too hard to graph. So for the second one, let's make that in blue. For g of x, we're looking at y equals 1/2 x plus 1. The slope is 1 over 2, which means we're going to rise 1 and run 2. And your starting point is the y-intercept 1. Okay? There are no constraints, you just have only one line for the entire domain for g of x. Okay, so let's do it. So you start from +1. You rise 1, run 2, and 2. Rise 1, run 2. Okay? So you can drop 1 and back up 2. So this line defines the second graph g of x. Okay, so there goes the line g of x. So there goes our system of functions right there. All right, the second part says how many values of x satisfy the equation f of x equals g of x? Explain your answer using the evidence from the graph. So one thing you want to recall is that the solution to a system of graphs is the point of intersection. Okay, so let's write that down. Recall f of x is equal to g of x wherever we have a point of intersection. The point of intersection. So what this question is asking is how many points of intersection are there between G and F? So we have only one point of intersection right here. Okay, one intersection. So since you have only one intersection, guess what? Only one x value satisfies this equation. F of x equals g of x. Okay, So let's write down the answer. Only one x value satisfies the equation f of x equals g of x. And then what's our explanation? Well, this is because there is exactly one point of intersection between f of x and g of x. Okay, so that's that. All right, let's take a look at question 37, the last problem on this exam. It reads, Franco and Carl went to a bakery to buy desserts. Franco bought 3 packages of cupcakes and 2 packages of brownies for $19. Carl bought 2 packages of cupcakes and 4 packages of brownies for $24. Let x equal the price of 1 package of cupcakes and y equal the price of 1 package of brownies. First part, question, write a system of equations that describes the given situation. Okay, so when you're dealing with unit cost and quantity type problems, there's a formula for the total cost. Okay, let's take a look at that real quick. So total cost is basically the unit price multiplied by the quantity. Okay, so in Carol and Franco's situation, quantities are provided for cupcakes and brownies, 3.2, 2.4, and the unit price are X and Y for cupcakes and brownies respectively. All right, so that's what we're going to be using to set up our system of equations. All right, so let's label the components of the different parts of the equation first before we start setting it up. So we have 2 individuals here, Franco and Carl. So let's put Franco here. This will be Franco's row. Okay, so for Franco, we're looking at the total cost for cupcakes. Okay, and then we're gonna add the total cost for brownies, and then that will equal the combined total. Okay, the combined total for brownies and cupcakes. All right, in the case of Franco, the unit cost for cupcakes is X, and let's take a look at it. So for Franco, for cupcakes, the unit price is X, and she bought 3 packages of cupcakes. So what's the total for cupcakes? It's going to be the unit price times quantity. Okay, or you can just write it as 3. The total number of cupcakes she bought times the unit price of X. All right, so that's how much she spent on cupcakes. And then for brownies, the unit price is Y multiplied by the total number she bought, total packages, which is 2. So you go 2 times Y. All right, and then the combined total, how much did she spend for both of them combined? So it says Franco bought 3 packages of cupcakes and 2 packages of brownies for $19 combined. So her combined total is $19. All right, let's take a look at Carol's situation. The unit cost is still X and Y. Carol bought, let's see, she bought 2 packages of cupcakes, so 2 total number of cupcake packages she bought times the unit price, X dollars each, will give her total she spent for cupcakes. And then for brownies, let's see, she bought 4 packages, so she bought 4 at Y dollars each. So 4Y is the total for brownies. And she spent a total of $24. Okay? So the system of equations that describes the situation is 3x plus 2y equals 19 and 2x plus 4y equals 24. All right, so this is the system of equations that describes the situation. All right, let's look at the second question. It says, on the set of axes below, graph the system of equations. Okay, so let's rewrite our system. We have 3x plus 2y equals 19 and 2x plus 4y equals 24. Okay, so these equations are provided in standard form, so we're going to graph them using intercepts, okay? So equation 1, equation 2, let's start with equation 1. We're going to use intercepts. So let's find our x-intercept first. If you want to find your x-intercepts, you just simply set y, the other variables, to 0, okay? So if you do that for equation 1, we're going to have 3x plus 2 times 0 equals 19. All right, that gives us 3x equals 19. Divide both sides by 3. And then x is going to be 19 over 3. Well, since we're graphing, we need a decimal approximation of this value. If you do that with your calculator, you end up with approximately 6.3 repeating. Okay, so that's what we're going to use. All right, so we have a point on the graph, 6.3, 0 for the first line. We need another point, okay? You need 2 points to define a line, at least 2 points. All right, so for the y-intercept, you just set x to 0. Okay, so you go 3 times 0 plus 2y, that equals 19. So that goes to 0, and then you have 2y equals 19. Divide both sides by 2. And then you have y equals 19 over 2 as 9.5 or 9.5. Okay. All right, so now we have another point. So the other point is 0, 9.5. All right, so if we graph these 2 points, these 2 intercepts, then we can use that to draw the first line. Let's take a look at the second one. So for the second one, the x-intercepts, to find that, you set y to 0. So looking at the second equation now, so let's do it. We have 2x plus 4 times 0 equals 24. So that goes to 0, of course. You have 2x equals 24. Divide both sides by 2. And you have x equals 12. So we have a point. The point here is 12, 0. So you look at this point, it's pretty, the x value is pretty big. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's a little bit bigger than our coordinate system. So we might have to go by 2's in order to be able to graph this point. Okay? All right, so keep that in mind. Always pay attention to your points when you're calibrating your axis so that all the points fit in nicely. Now for the y-intercept, we're going to set the other coordinate equal to 0. So now you're going to have 2 times 0 plus 4, y equals 24. Okay, let's see. That goes to 0, so you have 4y equals 24. Divide both sides by 4, and you have y equals 6. That yields another point, which is x is 0, 6. All right, so let's go ahead and graph our points. Remember, we're counting by 2's, okay? So this is 2, 4, 6. And then for our y's, let's see. 6, 9, 0. We don't have to go by 2's for our y's. could just leave it regular. It's going to skew our graph a little bit though, but that's fine. All right, so this will go by 2s, 2, 4, 6, 8, 10, and then this one we can just go by 1s. Okay, 1, 2, 3, 4, 5. And this coordinate system are bigger, than we could have, gone by 1s, but that's not the case here. Okay. All right, so let's graph the graph 1 first, the blue one. So 6.3 is somewhere here and 0. And then the other one, 0, 9.5. So 6, 7, 8, 9. 6, 7, 8, 9. 9.5 dead in the center. Okay, so that's the first line. All right, so just connect the two dots, and that's the line for Franco. All right, so for Carol, we have 12, 0. Let's draw that in green, 12, 0. That's her intercept. And then I think it's 0, 6, yeah, 0, 6 right here. Just connect the two dots, and that's it. All right, so there goes the second line for Carol. Okay, so there goes the graphical representation of your system of equations. All right, let's take a look at the last question. It says determine the exact cost of one package of cupcakes and the exact cost of one package of brownies in dollars and cents. Justify your solution. So let's see. If we go back to the graph that we have right here, sometimes you could use a graph to find the solution to a system of equations. Okay, so the blue one is 2x plus 4y equals 24. And then the blue one is 3x plus 2y equals 19. Now, in this case, the point of intersection is not a lattice point. It doesn't fall nicely on the intersection of the x and y coordinate grids. So at best here, you can give an approximate solution graphically. So since we've been asked to find the exact solution, we have to use an algebraic method. Okay, we cannot use the graphical method here. Okay, so let's go ahead and take a look at the system of equations again. So we have 3x plus 2y equals 19, Franco's equation, and then 2x plus 4y equals 24. Okay, so the exact cost, unit cost of both of them are basically x and y as we indicated earlier. Now to solve the system of equations, we can either use substitution or elimination. Let's call this 1 and call this 2. Whenever you have it in standard form, both of them, it's always a good approach to use elimination. Okay, so let's see. We want to eliminate either the x's or the y's. Whichever one is easier to create an opposite for, that's the one you want to use. Okay, I can easily make this y term the opposite of this one by multiplying by -2, and you're done. But if you wanted to eliminate the x's, you have to make this and this opposites. Okay, so you have to convert this to, let's say, -6 by multiplying by -3, and then you have to convert this to +6 by multiplying by 2. Okay, so making the y's opposites is faster because you just multiply one equation by a constant to make it the opposite. All right, so we're going to multiply equation 1 by -2. So what does that give us? We have -6 plus -4y equals -38. Now, one thing you want to be really careful about is you want to ensure that the constant you're scaling that equation by is distributed to every single term in that equation. Okay, sometimes students just multiply 1 and forget the other 2, or multiply 2 and forget the third one, but make sure that that number is distributed across the entire equation. Okay, all right, so we have that, and then you're left with the second equation, 2 remains unchanged, equals 24. Now we're looking good because if you look at the y's, you notice that they are opposites. Okay, so when you combine both equations, you end up with -4x, -6 plus 2 subtract and keep the sign of the bigger. And then here, negative 38 plus 24, you subtract and you keep the sign of the bigger, so negative 14. To finish this off, divide both sides by negative 4. That leaves you with x equals, you could divide top and bottom by the GCF, which is negative 2 in this case. All right, if you do that, you end up with 7 over 2. In dollars and cents, that is $3.50. Okay, now we're done with x. To find y, we can just substitute 7 over 2 for x. And now I could put it in 1 or 2, but whichever one will enable me to eliminate this 2 denominator, that will be preferred, okay? Equation 2 has a 2 here, so I'll rather use this one because this one I have been working with a fraction for a long time, and that wastes time, okay? So let's pick equation 2. Substitute 7 over 2 for x in equation 2. If you use the first equation, you get the same answer, but it'll take you longer to arrive at the correct solution. So just use the second equation, equals 24. The 2's divide out as expected, and we have 7 plus 4y equals 24. So just subtract 7, divide by 4, and you should be done. All right, subtract 7. We have 4y equals the positive 17, and then divide both sides by 4. And you have y equals 17 over 4, which is the same thing as 4 remainder 3, right? No, actually remainder 1. 4 times remainder 1, 4 1/4. So it's 4 1/4. In dollars and cents, it's $4.25, just 1/4. Okay, so let's write down the meaning. The unit cost for our cupcakes is $3.50 each. And then the unit cost for brownies is, let's see, what is it? $4.25. Okay, so that's that. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation or review of the Algebra 1 Regents exam, Common Core version, please give us a thumbs up. Your positive feedback is very valuable to us. Any questions or comments, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other great math tools such as this. And do visit math.serve.com for more great tutorials. Thanks again for watching and have a wonderful day.